Good morning, students. In the last lecture, I have discussed the one of the non-aqueous solvent, that is liquid ammonia. Now today I will discuss another non-aqueous solvent, that is liquid dinitrogen tetroxide. So in this lecture, we will discuss this non-aqueous solvent, that is liquid dinitrogen tetroxide. So let's start with that solvent, that is liquid dinitrogen tetroxide. Now this solvent, like liquid ammonia and sulfur dioxide, is also a non-aqueous solvent. Now it has, according to the classification that we have did earlier in the previous lectures, so it is non-protonic solvent. Non-protonic solvent means it has no hydrogen atoms. As there is no hydrogen atom in this, because liquid dinitrogen tetroxide is N2O4. So in this there is no hydrogen atoms. As it contains no hydrogen atom, so therefore it is a non-protonic solvent. So for this type of solvent, when there is no hydrogen, earlier we have discussed that those who have a capability, or those who release H positive ion, they act as an acid, and those who will release those which has a capability to give OH negative ion, they are base. But now in this solvent there is no H atoms. Then how will you say that this liquid nitrogen tetroxide is an acid or a base? Then for that solvent, it is better to use the Lewis definition of acid and base. According to Lewis definition means, what is base and what is acid? Base which have a tendency to donate a electron to the other atom, which have a tendency to donate a electron pair to another atom. And acid is a which have a tendency to accept a pair of electrons. So we have to use Lewis definition of acid and base for this liquid dinitrogen tetroxide. Liquid dinitrogen tetroxide has a convenient liquid range and interesting chemical properties. It can easily be prepared and purified. Hence, as it is easily prepared and purified, so it is widely used as a medium for chemical reactions and as a reactant in liquid phase. Now some of the physical properties they are given in this table, which represent that a liquid N2O4 that has a melting point 281.4 Kelvin, means 281.1 Kelvin, and a boiling point is 294.1 Kelvin. The density is 1.493 and the dielectric constant is 2.42. It has a low dielectric constant, that is 2.42 at 291 Kelvin. It means that it is a poor solvent for ionic compounds, but it is good solvent for organic compounds. Organic compounds, what are organic solutes? What are organic solvents? For example, many organic solutes like alkenes, halo, nitro compounds, carboxylic acids, all these organic compounds, organic solutes, they dissolve in liquid N2O4 because it is a good solvent for organic compound. Okay, it is a poor solvent for ionic compounds. So the generally that alkenes, halo, nitro compound and carboxylic acids, they dissolve in liquid N2O4. So when they dissolve in this, it shows Lewis acid character and it is a strong oxidizing agent. So N2O4 is a strong oxidizing agent. So it oxidizes many reducing agent. It oxidizes many reducing agent. So we have to take care. We have to take an extreme caution. Okay? Caution must be exercised while carrying out the reaction of reducing agents, particularly the organic substances in this medium, because of the possibility of such substances getting oxidized explosively. As it is a good oxidizing agent, that's why it oxidizes many reducing agent. So we have to take care, we have to take a proper precautions while carrying out the reaction of these solvents, because there is a possibility of such substances getting oxidized explosively. So these are the points, important points. Liquid N2O4 is a poor solvent for ionic compound but good solvent for organic compounds. So it shows Lewis acid character. It is a strong oxidizing agent. So it oxidizes many reducing agent. So the proposed auto ionization of an liquid N2O4 is this N2O4. When two molecules of N2O4 reacts, then what will it will form? Nitrosyl ion, that is 2NO positive plus 2NO3 negative. Clear? If 2 moles of N2O4 they will react, they will form 2NO positive, that is nitrosyl ion, plus 2NO3 negative, that nitrate ion. So the auto ionization of liquid N2O4 occurs to a very small extent. This auto ionization of liquid N2O4, they will go to a very small extent because of its low conductivity. However, their auto ionization can be prompted by solvent, by using the solvents with high dielectric constant, such as nitromethane, or you can say, or with having a donor solvent like MECO2ET, ether, diethylnitrosamine. So you can use such type of solvent to prompt the auto ionization of liquid N2O4. So this is a general reaction when this N2O4 and plus NDS means we are using donor solvent. So NDS means DS means donor solvent. So donor solvent, you can take nitromethane. I have told you earlier, nitromethane, ether, diethylnitrosamine. You can use these type of solvent as a donor solvent. So when it will react with a donor solvent, they will form this type of complex DSN dot N2O4. So these type of complex, they have a higher auto ionization. So we can increase auto ionization, we can prompt the auto ionization by using the solvent with high dielectric constant. So as shown in this above these reactions, auto ionization increases because of ion dipole interactions between the donor solvent and the ion. Clear? So these donor solvents also help in stabilizing these ions. So this is all about the physical properties of liquid ammonia, that it is poor solvent for ionic compound, good solvent for organic compound, Lewis acid character, strong oxidizing agent, and here the auto ionization of this N2O4. So this auto ionization, they occurs to very small extent, but we can increase the auto ionization by using the solvent with the high dielectric constant. So it will increase because of the ion dipole interactions between the donor solvent and the ion. So these donor solvent can help in stabilizing these ions. Now next we will discuss the chemical reactions of liquid N2O4. So these are the chemical reactions that occur in liquid N2O4. The first one is the acid-base reaction. As you know, the auto ionization of liquid N2O4 can be represented as N2O4 dissociate into NO positive plus NO3 negative. NO positive plus NO3 negative. So according to solvent system concept, substances producing NO positive ions that act as a acid behave as a acids in liquid N2O4. Means, for example, NOCl, NOBr, they behave as a acids in N2O4. And the substance producing NO3 negative ions like AgNO3, tetraethyl nitrate, they behave as a base. So when a solution of NOCl in liquid N2O4 is treated with solid silver nitrate, then precipitate of AgCl is formed. Because NOCl is an acid. Why it is acid? Because they have a NO positive ion. So the substances which have NO positive ion, they act as an acid. So NOCl is an acid and AgNO3 is a base because it has NO3 negative ion. So the substances which contain NO3 negative ion is a base, and when acid and base they will react, they form a salt. Okay, this will clear from the simple example. If we take the simple example of HCl and NOH, we are saying that HCl is an acid because it contain H positive ion. So HCl is an acid, and NaOH is a base because it contains OH negative ion. Similarly, those which contain NO positive ion in N2O4, they act as bases, acid, and the substances which contain NO3 negative ion behave as a base. So when HCl plus NaOH, that acid or base, they will react, they form a salt plus water, that is NaCl plus water. So this is a neutralization reaction. Neutralization reaction, because acid plus base, they will give rise to the formation of salt. As we talk about in case of liquid ammonia, in liquid ammonia, the substances which contain NH4 positive ion, they act as an acid. So ammonium chloride is an acid here, and the substances which contain NH2 negative ion is a base. So KNH2 is a base here. So when acid plus base will react in liquid ammonia, they will form KCl, which is a salt, plus 2 moles of ammonia molecule. So these are the reaction of acid base reaction in liquid N2O4, in water, and in ammonia. So we are comparing the acid base reaction in aqueous and non-aqueous solvent. In non-aqueous solvent, we are taking liquid ammonia and N2O4. So next is, the next reaction is NOCl act as an acid in liquid N2O4. Now here NOCl is an acid, they will react with tin and they form tin dichloride plus 2 and 2 moles of NO. And here 2 moles of HCl plus zinc HCl, when we are talking about the aqueous solvent. In water this reaction take place, whereas the NOCl plus tin, their reaction is taking place in N2O4 as a solvent. HCl plus zinc is take place in the water molecule, in water. So they will form zinc chloride plus H2. So these type of reaction, they are considered as an acid base reaction. The second type of reaction is complex formation reaction. So some of the complex formation reactions are also reported in liquid N2O4 medium. So when a solution of diethyl ammonium nitrate, that is XC2H5 twice NH2 NO3. So this is a solution of diethyl ammonium nitrate in liquid N2O4 is treated with zinc nitrate, means ZnNO3 twice. So when this will treat with zinc nitrate, a nitrato-zincate complex is formed. So that complex that is formed, the product that is formed, that is the nitrato-zincate complex, is formed when you treated diethyl ammonium nitrate in liquid N2O4 with zinc nitrate. So complex is formed. This is a complex formation reaction. So this reaction is similar to the reaction occurring in water and liquid ammonia. So these reactions, you can see the first case. In this, zinc hydroxide, they react with the 2 moles of sodium hydroxide. This reaction takes place in the solvent water. This is an aqueous solvent reaction. So this also forms a complex formation reaction when you are using water as a solvent. So this complex is formed when you treat zinc hydroxide with sodium hydroxide. And next is a reaction when you take zinc NH2 twice plus KNH2 in liquid ammonia, then the product that is formed, that is also a complex formation reaction. So here these are the examples of complex formation reaction in liquid N2O4 as a solvent, that is a non-aqueous solvent, in water as a solvent, that is aqueous solvent, or in liquid ammonia as a solvent, it is also non-aqueous solvent. Next reaction is a solvolysis reaction. As you know, what do you mean by solvolysis reaction? As the heading indicates, solvo plus lysis means in which the solvent molecule break down into 2 or more parts, and one of the part will react either one of the part of either of the solvent, they will react with the reactant or solute molecule. So in this, the solute molecule, that is solvent, they break down into 2 parts, and that in one out of these 2 parts, one part will react with the solute. So this here in this reaction, solvolysis reaction, first you have to take the example, that is diethyl ammonium chloride in liquid N2O4 undergoes solvolysis. So this is the C2H5 twice NH2, that is diethyl ammonium chloride. They in liquid N2O4, this liquid N2O4 first it undergo dissociation. First it will break down into two parts. Which part? That is NO positive plus NO3 negative. So I will tell you how this will dissociate into two parts. Now this is a solvent here, N2O4. So in solvolysis reaction, what will happen? First this N2O4 break down into two parts, that is here like this, N2O4 undergo dissociation, that is NO positive plus NO3 negative. First this solvent undergo breakdown into two, this split up into two parts, NO positive plus NO3 negative. Then this NO positive, they react with the negative part of this and form NOCl, and NO3 negative react with the positive part of the solute and they form C2H5 twice NH2 NO3. Similarly in magnesium perchlorate, again N2O4 is dissociated into NO positive and NO3 negative and is hydrolyzed in liquid N2O4, and they give rise these two products MgNO2 twice plus 2NOClO4. So these are the product of solvolysis reaction. This LiCO3 gets solvolyzed in presence of traces of water. So this will also solvolyzed in N2O4 with some traces of water. They will form LiNO3, 2 moles of LiNO3 plus N2O3 plus CO2. So these are the products when Li2CO3 is taken as a reactant. Solvolysis of halide is an excellent method for preparing anhydrous metal nitrates which are difficult to prepare. So halide, solvolysis of halide, they also used to prepare the anhydrous metal nitrate as it is difficult to prepare. So this, that is zinc X2, that is the solvolysis of halide. Zinc X2, in this X2 is a halide, H halogen, X is halogen, any halogen you can take, chlorine, bromine, iodine, any of the halogen you can take in. So we are in general writing X, zinc ZnX2 plus 2N2O4. First N2O4 undergo dissociation into NO positive and NO3 negative, and then it will react with the zinc halides and then they will form 2NO positive plus X2. X2 is your halogen. If you are taking Cl, then it will form Cl2. If you are taking Br, then Br2 will form. If you are taking I, then I2 will form, plus ZnNO3 twice. So these are the example of solvolysis reaction. Next is the reactions with metal. Now very reactive metals like alkali metal, alkaline earth metals, they react with the liquid N2O4. These reactions are similar to their reaction with water. So these reactions, they are similar as the reaction in water. For example, sodium react with N2O4, they form NO plus NaNO3. NaNO3, again in this N2O4, they first dissociate into NO positive plus NO3 negative. So NO positive as such and NO3 negative will goes into with Na. What happened in this reaction I will tell you. Wait. First this Na, they will form Na. First they will dissociate into Na positive plus electron, and this N2O4 dissociate into NO positive plus NO3 negative. So this NO, they will take electron from this. So by gaining this electron they will become NO, and this NO3 they will combine with the Na positive and they form NaNO3. Similarly, when lithium reacts with N2O4 they form NO plus LiNO3, and two molecules of lithium when reacts with two molecules of water they will form H2 plus 2 LiOH. So these are the reaction with metals. Now, addition of HCl to water increases the reactivity of water towards metals. Similarly, addition of, if you add HCl in water, then the reactivity of water increase because the ion formation take place in this. Similarly, addition of NaCl to liquid N2O4 also increases its reactivity towards metals like zinc, iron, tin. So this zinc, they react with 2 moles of NaCl in liquid N2O4. They form zinc chloride plus 2NO. And say tin Sn plus 4 NaCl in liquid N2O4. They form NO2 SnCl4 plus 2NO. So these are the reaction of metals with liquid N2O4. So like aqueous acids and bases, liquid N2O4 reacts with metals like zinc and aluminium in presence of nitrate solution. So here is an example of this when zinc is reacting with the complex and they form another complex formation take place. Next is the solvate formation. So nitrates of many transition metals like zinc, copper, iron, etc. they react with N2O4 and form solvate. Solvate means complex formed between a solvent and a dissolved species. So that the complex that is formed is known as solvate. So that they will form solvate. Like these are the example of solvate. For example, CuNO3 twice dot N2O4, FeNO3 twice dot N2O4. That is a complex between a solvent and a dissolved species. तो इसमें डिजॉल्व क्या हुआ है, फर्स्ट केस में, फर्स्ट एग्जांपल में CuNO3 ट्वाइस को हम डिजॉल्व कर रहे हैं एंड सॉल्वेंट क्या है N2O4. सो दिस इज अ लूजली बॉन्डेड कॉम्प्लेक्स between solvent and dissolved species. Second, similarly N2O4 is a solvent and the dissolved species FeNO3 twice. And third one UO2 NO3 twice dot N2O4, and fourth one is zinc NO3 twice dot 2 N2O4. So here is the solvent formation also take place in liquid N2O4. So there are certain reactions which cannot be explained on the basis of autoionization of N2O4 mentioned earlier. So reaction of N2O4 with BF3 gives NO positive and NO2 positive. So formation of these compounds cannot be explained on the basis of the proposed autoionization. So it can be explained by assuming the autoionization they will undergo in a different way. For example, N2O4 they will dissociate into NO2 positive plus NO2 negative. So there is no experimental evidence for the proposed autoionization of liquid N2O4, but they explain the chemistry of reaction satisfactorily. So what type of questions they come from this topic? Discuss the physical and chemical properties, or you can say the chemical reactions of non-aqueous solvent, that is liquid dinitrogen tetroxide. Or another way they can ask, with reference to liquid N2O4 discuss the following reactions like acid base reaction, complex formation reaction, solvolysis reaction, in this type. Or they can ask another question that can be asked from this topic, define the term acid and base with reference to liquid ammonia and liquid dinitrogen tetroxide, give some suitable examples. Then you have to mention it. Acid are those substances which release NO, which contain NO positive ion, and base which contain NO3 negative. So you have to write this type of answer and then give one reaction In example of acid and base neutralization reaction, you have to mention all this in this type of question. Or with reference to liquid N2O4 as a solvent, give two balanced equation for each of the following reaction. For example, acid base reaction, complex formation reaction, solvolysis reaction, metal reactions. So in this you have to write the reaction, balance it, all the reaction. Acid base reaction you have to be tell, complex formation reaction, how complex will form in the presence of liquid N2O4. Solvolysis, how solvent, that is liquid N2O4, dissociate into two parts, and one part how it will react with the solute molecule. And the metal reactions. So all these reaction you have to be discuss with a chemical reaction. Chemical reaction you have to be write with balanced equation. So these type of questions they can be asked from this solvent. So in the next lecture we will discuss another topic. So in the meantime, if there is any doubt, you can write the question in the chat box. I will try to give the answer of that question. So thank you.